Good day. Today we are on lesson number 10, and then this is our final lesson for this chapter, differential calculus. In the previous lesson there was an activity which was activity 9. Here are the answers. The chapter is still differential calculus, and today's lesson, rate of change. Okay, so for y equals to f of x, we have f prime of x equals to the limits of f of x plus h minus f of x all divided by h as h approaches 0, which is the first principle. Therefore, for y equals to f of t, we will have f prime of t equals to the limit of f of t plus h minus f of t all divided by h as h approaches 0. And then remember, I told you that this f prime of x can also be written as dy over dx. So here we have f prime of t. It means it can also be written as dy over dt, meaning that we are differentiating the function of y with respect to x. Therefore, dy over dt equals to the limit of f of t plus h minus f of t all divided by h as h approaches 0. We can rewrite this as dy over dt equals to the limit of change in y over change in t as change in t approaches 0. With change in t getting closer and closer to 0, we get dy over dt equals to the instantaneous rate of change of y with respect to x. Example 1. Okay, during an experiment, the temperature T in degrees Celsius varied with time T in minutes according to the equation T of T equals to negative T cubed plus 6T squared plus 49, where T is from 0 to 10. Determine, number A, the temperature when T equals to 3 minutes. Number B, the rate at which the temperature was changing at the end of the first 3 minutes. Number C, the time interval during which the temperature was increasing. Number D, the maximum temperature reached during the experiment. Solutions. Number A, we have this function which is given there. T of t equals to negative t cubed plus 6 t squared plus 49, and then we are asked to determine the temperature at time t equals to 3. Therefore, in the place of t we are going to substitute 3. We have temperature equals to t of 3 equals to negative into 3 cubed plus 6 into 3 squared plus 49, and this gives us 76 degrees Celsius. Number B, we have this, so it means determine, in fact we are determining the instantaneous temperature. Therefore, it's dt over dt, we differentiate, equals to negative 3t squared plus 12t. And then at the end of 3 minutes, it implies t equals to 3, meaning that we are going to substitute t equals to 3 into this one. Therefore, we have dt over dt equals to negative 3 into 3 squared plus 12 into 3. And then the answer is 9 degrees Celsius per minute. Number C, we have t of t equals to negative t cubed plus 6t squared plus 49. So, for this temperature to start increasing, it means the rate or the instantaneous temperature should be greater than 0. Therefore we differentiate, and then we make this to be greater than 0, and then we factorize this, then we solve. When we solve, we find that between 0 and 4 the temperature will be increasing. So we have 0 is less than T, it's less than 4. And then number D, we let T prime of T equals to 0 because we are determining the what? We are determining the maximum temperature. So for minima or maxima, we differentiate, and then we equate the gradient to 0, meaning that here we have T prime of T equals to 0. Therefore we have negative 3T squared plus 12T equals to 0, and then we factorize, then we solve for T equals to 0 or T equals to 4. Therefore for maximum temperature, it means we are going to take T equals to 4. Therefore maximum temperature reached is T into 4 equals to negative into 4 cubed plus 6 into 4 squared plus 49, and this gives us 81 degrees Celsius. The calculus of motion. If x equals to f of t is the equation of motion which gives position at time t, then v equals to dx over dt is the velocity at time t, and a equals to dv over dt is the acceleration at any time t. Example 2. The motion of a particle described by x of t equals to 5t squared minus 2t. Number A, find the velocity of the particle at time t equals to 2 seconds. Number B, find the acceleration. Solutions. Number A, for the velocity, we differentiate the given function. V equals to dx over dt equals to 10t minus 2. At time t equals to 2 seconds, v equals to 10 into 2 minus 2 equals to 18 meters per second. And then number B, for the acceleration, we differentiate the velocity. Therefore, we have dv over dt equals to 10 meters per second squared. This was our last lesson.